Question 3 is very similar to question 2. We're going to start off by putting the totals at the end of all these things. The females, adding up the females here, we've got 100. The males, adding up the males here, we've got 200. That makes a grand total of 300. Now coming downwards, the adults, 120. The social ones, that's 60, isn't it? And the juniors, 120. Let's just check that they add up to 300 as well, and they do. Now I'm going to read the questions. Find the probability that a female member is chosen. Females, what do we have? We had 100 females, didn't we? So we've got 100 out of the 300, and cancelling it down just to 1/3. Find the probability that a junior won. Well, there were 120 juniors, weren't there? So it's 120 out of 300. And again, cancelling that down, divided by 60 gives us 2/5. And lastly, an adult member is chosen given that it's a male. So we know we're in the males. We can ignore all the females and just take these males here. We're only talking about those. We know there's only 200 of them. So it must be out of 200. And it's given that it's male, we want an adult. The adults are 95. So I've got 95 out of 200, and that can cancel down with 5s into 19 over 40. The interesting bit of this one is actually the last bit, this little bit tacked on the end, that if you're going to take three members, well, the first person, you've got 200 people to choose from. But the second person, you've already chosen one, so there's only 199 left. And the third one, taking another one away, so there's only 198 left. And this time we want an adult, a social, and a junior. So the adults, there were 120 of them. The socials, there were 60 of them. And the juniors, there were 120 of them. This is actually the probability here of getting in order adult, social, junior. But because we don't care which order this is going to be in, we could have adult, social, junior, or adult, junior, social, or social, junior, adult, or social, adult. All these different ways of doing it, all these 6 different ways of doing it, we're going to have to times that answer by 6. No such problem with the last one, though. If you want all 3 of them to be adults, there's only one way of doing it. You've got to get an adult on the first one, an adult on the second, and an adult on the third. But again, this time the thinking is there's only 120 adults to choose from. When you've chosen one of them, there's only 119 of them left, and then there's only 118 of them the next time. And those two have caused some interest in other years.